So continuing with chapter 5 today, moving on to some more factoring actually. So there's still a lot more with factoring that we have to learn. So just building off of kind of what we did in the previous chapter of chapter 4, but like I said, there is more to factoring. We still haven't learned everything yet. But at the top, a prime polynomial definition is just a polynomial that cannot be factored. So polynomials that cannot be factored. So kind of like a prime number. You know, if you have a prime number like 3, you know the only factors are going to be 1 times 3 and that's it. It's a prime number. Okay, so prime polynomial, same idea. You can't actually factor it. So here are some examples of prime polynomials. X squared plus 4, that is not factorable. It's solvable, so you can still actually solve for x, but you can't factor it. So there's no way, shape, or form to factor. Here's another example. So something like this, x squared minus 12x minus 11. You could sit here all day, but I'm telling you right now that quadratic is not factorable. There are no two numbers that multiply to be negative 11 that also add to be negative 12. Okay, so those are prime polynomials, cannot be factored. But now, so moving into some newer stuff, something that we did learn before, something that is factorable is something like x squared minus 25, which is called a difference of squares. That just factors into x minus 5, x plus 5. So that should look familiar to you because what we're actually doing next is a sum of two cubes. So a sum of cubes, then also a difference of two cubes. So sum of cubes, a difference of cubes. Kind of same idea as what a difference of squares is. Again, difference of squares just means you're subtracting two perfect squares. So x squared is a perfect square. I can take the square root, that's just x. 25 is a perfect square. Square root of 25, that's just 5. That's why we get x minus 5, x plus 5. So if you look at these examples, if you have a sum of cubes, sum just means you're adding. We're adding two perfect cubes. So as an example, a cubed and b cubed. Okay, how it factors into what you see after the equal sign. There it is, factored. Okay, but let me just break this down to you. Let's go down to the other example that they have, x cubed plus 8. So again, it is a sum. You are adding two perfect cubes. You can take the cubic root of each term and then expand it out and get what you have factored. Okay, let me erase this right above it because I want to be using some of this right above. But x cubed, like I said, that's a perfect cube. If you take the cubic root of x cubed, that's just going to be x. And if you take the cubic root of 8, that's going to come out to be 2. So let me show you real quick in the calculator how you punch in a perfect cube or how you take the cubic root of a number. So if I want the cubic root of 8 for an example, cubic root of 8, you type in 3 first, and now you want to shrink it down, which is going to be the green button the far left with the square root with a little x in front of it, so right above the square root button. So if you go to second, and then again, you see the 3 actually shrink down too. Okay, so that's called an index, that little number in front of the radical. So you want to take the cubic root of 8, and again, it comes out to just be exactly 2. The reason why is because 2 times 2 times 2, 2 times itself 3 times, is going to be 8. So that's why the cubic root of 8 is 2. Okay, so that's exactly what you're asking yourself. What number times itself 3 times is going to be this number? Well, in this case, it'd be 2. Okay, so using those two numbers, using x and using 2, the first one's going to be a binomial every single time. So when you start to actually factor it, it's going to be the binomial, followed by a trinomial. So binomial, trinomial, here's the setup. So with the signs, what you're going to do, looking at the signs, so you have a plus sign originally, right? X cubed plus 8. The binomial is going to be the same sign as the original, so also a plus sign, followed by the opposite sign, which is a minus, followed by a plus. So as long as you remember this saying, same, opposite, plus, you'll never get this wrong. Same, opposite, plus. Okay, then everything else, if you fill in the numbers, so in the binomial, it's just simply x and then 2. So x plus 2. Then the trinomial, it's the first term, which is x squared. Then you have 2 squared in the back, which is obviously just 4. And then you just want to multiply 2 times x for the middle. So 2x goes in the middle, and that's it. Okay, so same thing too with a difference of cubes. Same exact idea. So again, difference means now you're subtracting two perfect cubes, a cubed and b cubed. So here it is factored. Okay, so coming over to the example again, if you take the cubic root of each term, so cubic root of x cubed would just be x. Cubic root of 8 again would just be 2. So here's how it works. Like I said, binomial followed by a trinomial. That's how it factors. Look at the signs first. So in the binomial, it's going to be the same sign followed by the opposite in the trinomial, followed by a plus sign. Okay, as long as you remember same, opposite, plus, again, pretty easy. And then just filling everything out, the binomial is just simply x minus 2. Trinomial, first term, which is x squared, so that's where the x squared comes from. 4 in the back is the last term, which is 2 squared, and then just multiplying 2 times x for the middle, so 2x. Okay, let's try a couple on our own now. So factoring each one, if it's not factorable, then just write that it's prime, but I'm going to let you guys know right now, these are all factorable. Okay, so number 1. First, setting up binomial, trinomial. Again, get the signs down, which are same, opposite, plus. Okay, now take the cubic root of each term. So if I take the cubic root of x, that's just x. Cubic root of 125, so if you don't know what that is, you can just punch it in. Again, if I type in 3, shrink it down, second, with a little x in front, cubic root of 125 comes out to be exactly 5. Again, the reason why, because 5 times 5 times 5 is 125. So that's just going to be 5. So using x, using 5, now just fill it all out. The binomial is just x plus 5. Trinomial, x squared, so again, first term squared in the front. 5 squared goes in the back, so that's 25. And now just multiply together, 5 times x goes in the middle. And that's it. You're factored. Okay, it's as easy as that. Binomial, trinomial, same, opposite, plus, and then just fill it all out. So number 2, same thing. Same idea, but first you actually have a GCF. You could take out of both of those. So if you look at them, you can definitely divide them both by 2. So if you take out a 2, you'd have x cubed minus 64 left over, which is still factorable. Okay, so you're still going to keep that 2 in the front. But now, binomial, trinomial, because again, that is a difference of cubes. If you take the cubic root of each, cubic root of x cubed is x, cubic root of 64 is 4. Okay, so first the signs. So again, it's the same sign, opposite sign, plus sign. Same, opposite, plus. And now filling out with x using 4. So x and 4, the binomial is just x minus 4. Trinomial, x squared, 4x, 16. So again, first term squared, the last term squared is going to be the last term of the trinomial. Just multiply 4 times x in the middle. Okay, there it is. There's everything all together. And the last one, number 3. So again, taking out your GCF first and foremost, which would be a 2 and an x. So if you take out a 2x first, you'll have 8x cubed plus 27y cubed. Okay, so once you take out that 2x, again, what you have left over is still factorable. That is a sum of 2 cubes. So keep the 2x in the front, your original GCF. Binomial, trinomial. Here's a setup. Again, the signs, same, opposite, plus, and now take the cubic root of each term. So if you take the cubic root of 8x cubed, that would just be a 2x. Take the cubic root of 27y cubed, that's going to be 3y. Okay, so the binomial is going to just simply be 2x plus 3y. Then the trinomial, be careful with this, because when you square 2x, right, 2x squared goes in the front, you want to make sure you square both of them. So that's actually 4x squared. When you square 3y in the back, same thing. You want to make sure you square both of them. Square the 3 and the y. So there'll be 9y squared in the back. And then multiply 2x times 3y for the middle, which is 6xy. And there you go. You got it completely factored. Okay, so sums and differences of cubes. And I just kind of threw this chart on here just to kind of refresh everything that we've known about factoring so far. So starting with the basics, GCF, sometimes it's all you can do is take out the greatest common factor and then you're done. So I have an example over here. If you have 4a cubed b squared minus 8ab, take out 4ab and then you still have a squared b minus 2 left over. Okay, difference of squares, I got an example, a squared minus b squared. So here's the new stuff if you want to highlight it. The newer stuff is sum of cubes. So here's an example, difference of cubes. There's your example. Trinomials, we did that last chapter, so we should know how to do that. Find two numbers that multiply to be c, that also add to be b. General trinomial when a is not 1, so if you have like a 2x squared, 3x squared, that's just going to be the guess and check. We talked about perfect square trinomials a lot last chapter, especially with completing the square. But we're also going to be doing this factoring by grouping, okay, which looks a little something like this. So we'll be going through that on the next page. Okay, so once you're ready, go ahead and turn the page. Okay, factor each polynomial, and again, if it's not factorable, then just write it being prime. So if you have 4 terms, 4 or more terms down here. So on the left-hand side, it talks about the number of terms. So any term, you could take out a GCF potentially. 2 terms, it could be a difference of squares, sum of cubes, or difference of cubes. 3 terms, trinomials, but if you have 4 or more terms, we're talking about a polynomial. Okay, this is how you want to factor is by this method called grouping. So let me show you guys how this works. So on the next page, how this is going to work, factoring by grouping, what you're going to do is group your first 2 and group your last 2. Make sure you bring that plus with the 3x. Okay, so if you have 4 terms, this is factoring by grouping. All you're going to do is take out the GCF in the first 2 terms. So between x cubed and 7x squared, the GCF would just be x squared. And when you take that out of both of them, you're dividing each term by x squared. What you'd have left is x plus 7. Same thing now with the next grouping, just take out the GCF, which would be positive 3. So I'm going to pull out plus 3, where I also get x plus 7 left over. Okay, and here's how you know you factored by grouping correctly. These have to match. They have to be perfect matches. Positive 1x, positive 7, make sure they're perfect matches. Because now completely factored, what you're going to have is your 2 GCFs come together for one binomial, x squared plus 3, followed by just one of those binomials. Although you have 2 of them listed, it's just x plus 7. And that's it. You're done factoring. Okay, it's as easy as that. That is factoring by grouping. So same thing for number 5. Just take out the GCF between the first 2 and the last 2. So GCF between 8y cubed minus 4y squared, you could take out a 4 and a y squared for both, or you'd have 2y minus 1 left over. So if you divide each term by 4y squared, this is what you'd have left, just 2y minus 1. In your second grouping, negative 50y plus 25, you could definitely take out 25, but you're going to want to take out negative 25 because, again, what you have left here has to match what's going to be left over here. So if you take out negative 25 instead of just 25, you will have perfect matches. Divide each term by negative 25, you would have a positive 2y like you want, and then 25 divided by negative 25 is negative 1. Okay, so again, your 2 GCFs come together. Bring these 2, that'd be 4y squared minus 25, followed by a 2y minus 1. Again, although there's 2 of them, you only want to list it once. But you can actually keep on factoring here. We're not done. Okay, we factored by grouping, so what? You're still not done. You can keep on factoring, hopefully you guys see it too, 4y squared minus 25, because that's a difference of squares. It is a difference between 2 perfect squares. So fully factored, I'll just bring it underneath here, because we're not going to do number 7 anyways, but this would factor into 2y minus 5, 2y plus 5, so that's the difference of squares, and the 2y minus 1 at the very end. Okay, so just as long as you have all 3 binomials, honestly, doesn't matter which way you list them, but you just basically want to keep factoring, keep factoring, keep factoring until you can't factor anymore. Okay, so even once you think you're done, just double check one last time. Can I do more? Is there more that can still be factored? Okay, so we're not going to do 6 or 7. We're not going to give you anything quite this crazy anyways. You won't see anything like this in the future, so I'm not going to worry about those. But moving on to now actually solving by factoring. Okay, so now that we know how to factor these, how do we actually solve them? So, the first one, number 8. So 8x cubed minus 343 equals 0. So this is a difference of cubes. It's a difference. I'm subtracting 2 perfect cubes. So setting it up, binomial, trinomial. Again, the signs are same, opposite, plus, and now take the cubic root of each term. So the cubic root of 8x cubed is a 2x. The cubic root of 343, and eventually you guys will have these memorized, because we're going to be doing a lot of cubes here in the future, but that's just going to be 7. Okay, so how this factors in the binomial is just 2x minus 7. The trinomial is going to be 2x squared, so that's 4x squared. 7 squared again goes in the back, so that's 49. And then multiply 2x times 7 in the middle, which is 14x. Okay, so we're done factoring. But now to actually solve this thing, okay, we're going to have 3 answers in the end. One answer just comes from setting 2x minus 7 equal to 0. So that's easy enough. You add 7 divided by 2, and get 7 over 2. Okay, there's one answer. But the second one, coming from this trinomial now, this is not factorable. You cannot break that down anymore. As much as you try, it's not going to be factorable. So if you can't factor a quadratic, like 4x squared plus 14x plus 49, if you can't factor it, what you're going to do is use the quadratic formula. Okay, every single time that you factor a sum or difference of cubes, so same with number 9, same with number 10, the trinomial, you have to use a quadratic formula. Okay, so here's a little refresher. Quadratic formula is negative b plus and minus the square root of b squared minus 4ac, and that's all over 2 times a. Okay, so if you plug everything into the quadratic using your quadratic that you guys have, the 4x squared, you would have negative b, so negative 14 plus and minus square root of b squared, 14 squared, minus 4 times 49. This is all over 2 times a, so 2 times 4. Okay, now simplify it again one step at a time. So you'd have negative 14 plus and minus the square root, 14 squared is 196. And now I'm multiplying negative 4 times 49. That's negative 784, all over 8, 2 times 4. Okay, underneath the radical still. 196 minus 784, that's going to be negative 14 plus and minus the square root. Again, if you subtract those two, you get negative 588. That's all over 8. Now you want to simplify the radical. So if you take the square root of negative 588, well, the fact that it's negative, we know it's going to be imaginary. So there should definitely be an I in my answer. But if I simplify the radical, so if I punch in just the square root of 588 positive, it tells me that it's 14 square root 3. Okay, so you can simplify it pretty quickly using your calculator, but this comes out to be negative 14 plus and minus 14i square root 3 all over 8. And one last final thing is that you can actually reduce this all down. So if you reduce everything down in this problem, divide everything, it looks like by 2 would probably be the most that we could divide it by. But you would get negative 7 plus and minus 7i square root 3, and that'd all be over 4. And that would be your 2 solutions. Okay, but that's 3 answers altogether. Again, technically, if you go back through, I can highlight all the answers. So here's one answer, and then here's 2 more. So that's 3 answers altogether. All right, so every single time you factor these things, again, this is what you have to do, quadratic formula. Okay, so let's just do one more. Number 10, we'll go through and solve that one. Let's just factor number 9. I'm not going to go through the whole solving process again, but just factoring, getting used to that. Again, how this would factor, there's no GCF, but it'd just be a binomial and a trinomial. The signs again, same, opposite, plus. And now if you cube root each term, the cubic root of 27x cubed is a 3x, and the cubic root of 8 would just be 2. So you'd have 3x plus 2 in the binomial, 9x squared in the front, 4 would be in the back, 2 squared, and then 3x times 2, that's 6x, goes in the middle. And now again, you'd want to solve it. Okay, so you'd have to do, like I said, the quadratic formula with the trinomial. You get one easy answer for the 3x plus 2, just set it equal to 0, you get a fraction. But you'd have to use the quadratic formula for the second part. Okay, number 10, let's go ahead and do this one. So factoring, binomial, trinomial, signs again, same, opposite, plus. And now take the cubic root. This would be r, cubic root would be 5. So r plus 5, r squared, 5r, 25 in the back. Okay, so now we have to solve it. Okay, just set r plus 5 equal to 0. There's one answer. R equals negative 5. Okay, now use the quadratic formula. So for the quadratic, the r squared minus 5r plus 25 quadratic formula. So we would have r is equal to negative b, so negative negative 5 plus and minus square root of b squared minus 4 times a times c, that's 25, all over 2 times a. Okay, now start simplifying. So negative negative 5, positive 5 plus and minus square root, that's positive 25. And now we have negative 4 times 1 times 25, think like quarters. That'd be minus 100. All over 2 times 1 is just 2. And now 25 minus 100, you get negative 75 all over 2. And again, when you take the square root of negative 75, we know that that's going to be imaginary, right? But if you take the square root of positive 25, just simplify it. Second square root 75, you get 5 square root 3. Okay, so that's going to be 5 plus and minus 5i square root 3 all over 2, and that cannot be simplified anymore. So that'd be my last two answers. Again, if you want to go through and highlight them all, you can. So we get r equals negative 5, and then 5 plus and minus 5i square root 3 all over 2. Okay? So now, let's move on to something hopefully a little bit easier. These next ones, so looking at number 11, first and foremost, to start factoring, again, there is a GCF. So if you look at all three terms carefully, you can take an x out of each term. So you take out your x, you'd have x squared minus 8x minus 9, which is still factorable. So we know how to factor this quadratic. It's just like it was back in chapter 4. So all I'm trying to do for this one is I'm trying to figure out what multiplies to be negative 9 and adds to be negative 8. So just using my c and my b term. So two numbers that multiply to be negative 9, add to be negative 8. So it's either 1 times 9 or 3 times 3. Obviously, it's going to be 1 and 9. As long as 1 is positive, 9 is negative. So fully factored, GCF out front, you'd have x plus 1 since it's positive, x minus 9 since it's negative. And now solving, you should get 3 answers for this one. So set each and every single term you see equal to 0. Starting with the GCF, x equals 0, that's one answer. Okay, set x plus 1 equal to 0, and you get x equals negative 1. Set x minus 9 equal to 0. Add the 9, you get x equals positive 9. And that'd be it. Okay? Number 12 is very similar to the previous problem. There's no GCF to start, so there's nothing you could take out of all three terms besides 1. But again, this is kind of just like a normal trinomial. If you're thinking about what multiplies to be 4 and adds to be negative 5, since it is a 1x the fourth. So again, what multiplies to be 4 and adds to be negative 5, so that's 1 times 4 or 2 times 2. It's definitely going to be 1 and 4. They both have to be negative. So again, two negatives multiplied is going to be a positive, and that's how I get my negative 5. But how this factors would be, it'd be x squared minus 1 and x squared minus 4. Where does the x squared come from? Well, it comes from this x the fourth. So again, typically, if we go back to the previous problem, when it was x squared, it's just going to be x and x the first, x the first. Well, now that it's x the fourth, now it's going to be x squared and x squared. Okay, if you FOIL those two binomials back together, x squared minus 1 and x squared minus 4, you should get, if you remultiply them back together, you will get x the fourth minus 5x squared plus 4. Okay, I'm not going to go through all that with you today, but again, just FOIL them back together and you will get exactly what you started with. Okay, but we're actually still not done factoring. Both of these can be factored more. These are both going to be a difference of squares. So fully factored, you would have, if you factor the first difference of squares, it'd be x minus 1, x plus 1. X squared minus 4 factored is x minus 2, x plus 2. And now we're set to solve. So solving this one from left to right, we should get 4 answers altogether. If you set each one equal to 0, x minus 1 equal to 0, you get x equals 1. Set x plus 1 equal to 0, x equals negative 1, so on and so forth, x equals 2, then x also equals negative 2. So you get 4 answers altogether. Okay? 13 for the next one. So x the fourth minus 16, this is just a difference of squares. It is a difference. You are subtracting two perfect squares. X the fourth is a perfect square and so is 16. So if you take the square root of each, square root of x the fourth would be x squared. Square root of 16 would be 4. So it factors into x squared minus 4 and x squared plus 4. So very similar to the previous problem, right? Where we had these difference of squares, x squared minus 1, x squared minus 4, similar idea. But now you have yet another difference of squares. X squared minus 4, that could be factored even more. So if you break that down, just like the last problem, this would be x minus 2, x plus 2. But the x squared plus 4 cannot be factored. There is no such thing as a sum of squares. There's only a difference of squares. There's a sum of cubes and a difference of cubes, but not when it comes to squares. So this will just stay x squared plus 4. Okay, so now we have everything completely factored. Now just start solving. Set x minus 2 equal to 0. Get x equals 2. Set x plus 2 equal to 0. Get x equals negative 2. And now for the x squared plus 4, what I'm going to do is use the square root property. I'm going to subtract the 4 and then square root both sides. Because again, when you take the square root of both sides of an equation, the square root property says you get positive and negative solutions. So when you take the square root of negative 4, well, square root of negative 4, we should know this from last chapter, that's just going to be plus and minus 2i. And that is 4 answers altogether. Positive 2, negative 2, positive 2i, negative 2i. There's all my solutions. Okay? Coming down to the next one. How we're going to factor this is by grouping. Again, if you look at it, you got 4 terms, so you have to factor by grouping. However, you do have a GCF to take out of all 4 terms first. Take a look at it closely. What can you pull out of all 4 terms? Take out a 1s. So then you'd have s cubed minus 4s squared plus 3s minus 12 equals 0. Okay, now factor by grouping. So once you take out that GCF, group your first 2, group your last 2. So you got that 1s from the very beginning, right? And then inside here, the GCF between the next 2 terms, or the first 2 terms here, s cubed minus 4s squared, that'd be an s squared. So you have s minus 4 left over. And then GCF between the next grouping, the 3s minus 12, you could definitely take out a positive 3. So again, you get s minus 4, which is a good thing. Again, these have to be perfect matches, s minus 4, s minus 4. So I know I'm done factoring. So fully factored, what we would have is the GCF from the beginning, followed by, again, the 2 GCFs here merged together as s squared plus 3, followed by an s minus 4. And now you want to solve it. Okay, so from left to right, set it everything equal to 0. Starting with the GCF, s equals 0, that's one answer. Set s squared plus 3 equal to 0. So again, square root property, just subtract the 3, square root it. S would be plus and minus, that would just be I square root 3. So as far as simplifying, just take the I out, friends, since it is a negative underneath the square root. And then you still have a radical 3 left over, or square root of 3 left over. And then setting s minus 4 equal to 0, just add the 4. So you get positive 4. Okay? Same thing for 15, except there is no GCF this time. So between all 4 terms, you can't take out anything besides 1. So just start grouping, first 2, last 2. So in your first grouping, take out an x squared. So you'd have x plus 5 left over. Second grouping, take out a negative 2. So you'd also have x plus 5 left over. Again, these have to match, which they do. They're both x plus 5. So your GCFs come together as x squared minus 2. And then x plus 5. So we're done factoring. Nothing more can be factored here. You don't have any differences of squares, nothing like that. So now start solving. Set x squared minus 2 equal to 0. And then you would add the 2. And then square root it. So x equals plus and minus square root 2. And then for the last one, set x plus 5 equal to 0. You get x equals negative 5. Okay, the very last one now, I'll go back to blue. Again, factoring by grouping, there's no GCF between all 4. So group your first 2, group your last 2. First grouping, take out an x squared, you'd have x plus 4. Second grouping, take out a negative 9, where you'd also have an x plus 4. And if you divide these both by negative 9, this is what you'd have, which again is perfect matches, x plus 4 and x plus 4. So GCFs come together, x squared minus 9, followed by an x plus 4. But you can still keep factoring now. Okay, again, you factored your factoring by grouping, your original 4 terms, but with what you have, when your 2 GCFs came together, x squared minus 9, this here can still be factored. That is a difference of squares. So fully factored, this would be x minus 3, x plus 3, followed by the x plus 4 from above, And now we can solve for 3 answers. So you should get x equals positive 3, negative 3, and then also negative 4 would be your 3 solutions. Okay, something you should notice too, I don't know if anybody caught on to this, but the degree of the polynomial actually tells you how many solutions you should have. So number 16, for example, the fact that this was an x cubed, right, to the 3rd power, well, I got 3 answers. The previous one is an x cubed. Again, you got 3 answers. Positive square root 12 and negative square root 12, that's 2 answers. And then negative 5, 3 answers. And then the previous one was s to the 4th power. We got 4 answers. We got 0, positive I square root 3, negative I square root 3. Again, that's 2 answers. So that's 3 so far. And then get s equals 4. So that's going to be 4 answers altogether. Okay, we're me using and applying this in the future once we get to our next section, but just something to take into account just to verify, do I have all my solutions? Again, right above it even too. So if you look at number 13, this was x to the 4th power, and we got 1, 2, 3, 4 answers altogether. Positive 2, negative 2, positive 2i, negative 2i. Before that, x to the 4th, we got 1, negative 1, 2, negative 2, so on and so forth. Okay, so that's kind of a dead giveaway. That's going to help you, again, when it comes to solving so that you know that you did everything correct. Okay, I know my students, you guys have some extra factoring practice if you'd like to try that. We got more sums and differences of cubes, factoring by grouping, and then quadratic likes. So if you want some extra practice, you can always do more of that. Otherwise, that's all I have for you guys today. All right, thank you for tuning in, and we will talk to you guys later.